Assalamu alaikum students. I hope you are doing well. You might have gone through the previous lecture where we covered the theoretical concepts related to the Boolean logic. Today we will solve some of the past papers related to the topic of Boolean logic. Please keep in mind one thing, that before 2023, this topic of Boolean logic was a part of paper 1, but in 2023, this is a part of paper 2. So let's say we start. There is one question in front of you, which is paper 2, variant 1, May-June session, 2023 year. Let's see the question. It is given that consider this a logic expression z is equal to not of a or b, not of a or b, and b XOR c. You're supposed to draw the logic circuit for this logic expression, and it is given that each logic gate must have a maximum of 2 inputs. So let's say we design this. First of all, we design this sub-expression, not of a. Not of a is, this is not of a or b. So let's say we have to OR them. So not of a or b. This is not of a or b. Let's say we call this as p, for instance. You can give any name. So we call this as p. Then the second sub-expression is b XOR c. So we can see b XOR c. Fine. This is the symbol for exclusive OR. B XOR C. Fine. B XOR C. Let's say call this as Q, for instance. So this is Q. And then what? P, this sub-expression, and Q. So it means that is Z. So P and Q, and this is Z. So P and Q, and this is Z. That's it. Fine. So this is the logic circuit. You may call this as not of a or just a bar or a prime. So this is a circuit for the given logic expression. Next, it is asked to draw the truth table for the same logic expression. Fine. So you can see that the logic expression which is given over there. So you can find out these sub-expressions. For instance, a bar, you need a bar. So you can find out over here the column of a bar. So that is simply what is a, that is just invert that. So a is 0 0 0 0. So a bar will be 1 1 1 1, and then from here onward is this 1. So a complement will be 0. Fine. Then what we need next is p, which is what? Which is a bar or b. Fine. So a bar, so we can find out that column for p, which is a bar or b. Fine. So P is A bar or B. So you have to OR A bar and B, these two columns. Fine. So just OR them. So 0 OR with 1 is 1. 0 OR with 1 is 1. 1 OR with 1 is 1. 1 OR with 1 is 1. 0 OR with 0 is 0. Then 0 OR with 0 is 0. Then 1 OR with 0 is 1. And 1 OR with 0 is 1. Fine. So you had made this column for P. Similarly, Q is what? That is B XOR C. You can use this symbol for XOR, or you can just write down B XOR C as you like. So this is Q. So you can make the column for Q, which is B XOR C. I mean, you have to know XOR B and C, these two columns. Fine. B XOR C. As far as exclusive OR is concerned, you know that if X and Y are the inputs, and you have to XOR them. So 0, 0, 0, 1, 1, 0, 1, 1. So exclusive OR output is true when both of the inputs are different. Otherwise, output is 0. So here you have to exclusive OR B and C, these two columns, this and this. So 0 exclusive OR with 0 is 0, different, 1. Both inputs are different. Output 1, same, 0, same, 0. Inputs are different. 1. Inputs are different. Output is 1, same. So output is 0. Fine. So you had made the column for Q, which is B exclusive OR C. So you made P and you made Q. Next output Z is what? That is P and Q. That is P into Q, or P and Q. So Z, which is P and Q. So you have to just AND P and Q, these two columns. And you know output of AND gate is 1 when both of its inputs are 1. So 1 into 0, 0. This is 1 into 1, output is 1. 1 into 1, output is 1. 1 into 0, output is 0. 0 into 0, output is 0. 0 into 1, output is 0. 1 into 1, output is 1. 1 into 0, output is 0. And that's it. So this is the truth table for this particular logic expression. That's it. Let's move to the next question. This is again question 2023 May-June session. Fine. So it is given that 4 logic gates and 5 standard symbols for the logic gates are shown. 4 logic gates, 1, 2, 3, and 4. So 4 logic gates are shown and 5 standard symbols. Logic gates and, or, not, NAND. These logic gates are shown and their corresponding symbols. This is the symbol for OR, symbol for not, symbol for AND, for NAND, and NOR. So these are shown to you. So it is asked to draw one line to link each logic gate to its standard symbol. Fine. So AND gate. You know, this is the symbol for AND gate. So you have to do what? You have to link this with its correct symbol. Then OR. This is, you know, the symbol for OR gate. So you connected this Then not as this particular, that is not. So you can connect this with this, and this is NAND, and NAND is this, symbol for NAND is this, so you connect this, and that's it. So very simple question. Fine. We go to the next question. Again, here 2023 May-June session, paper 2, variant 2. Over here, some logic expression is given to you. X is equal to A or B, and not of B and C. So these are the two sub expressions. One is this one, another one is this one, and those are connected through AND. Fine. So you have to draw the truth table for that. You can write down this Boolean expression, this logic expression in the form of Boolean expression if you want. A or B, symbol for OR is this. You may call this as P. So here you can draw the column for P. Similarly, not of B and C. Not of B is represented in Boolean expression as B prime, and C, and means dot. So this is for this, and then you have to connect, let me call this as Q, and then you have to AND P and Q. You have to AND P and Q. You can simply write that X is P and Q. This is P, this is Q, and so let's say now we draw the truth table. So first of all, if there is some not, for instance, not of B or B prime, so you draw a column for B prime. Fine. So let's say B prime is just not of B. So where B is 0, B bar will be 1, or B prime will be 1, or where B is 1, not of B is 0. So it is 1, 1, 0, 0, 1, 1, 0, 0. Fine. So this is not of B, just B prime. Then let's say we find out expression for P, which is A or B. We can write down it like this, A or B. So for this, we have to OR A and B. We have to OR A and B. So OR gate output is 0 only when both. So 0 OR with 0, 0. And this one OR with 1, and this one. Fine. So you have drawn the column for this P, which is A or B. Similarly, draw another column for Q, which is B prime and C, or not of B and C. Fine. So let's say Q is B prime into C. So here we have to AND B prime and C. So this is B prime and this is C, and we have to AND them. So AND, output of AND is true when both of its inputs are true. So 0 into 1 is 0, 1 into 1 is 1, and 0, 1 into 0 is 0, 0 into 1 is 0, 1 into 1 is 1, 0 into 0 is 0, 1 into 0 is 0. Fine. So B prime into C, you just ended these two columns. Fine. So output is 1 where both of its inputs are 1. One is here and other one is here. Fine. Next, what is final output X? That is P into Q. I mean, this is P, this is Q, and you have to just AND to get X, which is the final output. That is P into Q. I mean, now you have to AND this P and Q, these two columns. Fine, P and Q. Just AND these two columns, 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, and 1 into 0, 0, 1 into 0, 0, 1 into 1 is 1, then 1 into 0 is 0, is 0, and that's it. So this is the truth table for this particular question. I hope it is clear. Let's move to the next question. Another question from year 2023, paper 2, variant 3. So let's say we solve this. We see first what is given in the statement. So there are 3 descriptions of logic gates. Each logic gate has 2 inputs, A and B, with one output X. Identify each logic gate, and then it is asked complete the truth table for each logic gate. Fine. So part A is the only time the output is 1, the only time output is 1 when both of its inputs are 1. That output is 1 when both of its inputs are 1. So what is the gate? Yes, that is AND gate. You know, the output of AND gate is 1 when both of its inputs are 1, otherwise 0. Further, it is asked that you have to draw the truth table. So output is 1 when both of its inputs are 1, otherwise output is going to be 0. That's it. Fine. Okay, move to the next part. The output is 1 when both of its inputs are different. Output is 1. It is said that output is 1 when both of its inputs are different. I mean, if A is 0 and B is 1, or B is 1, A is 1, B is 0, when both of its inputs are different, output is 1 when both of its inputs are different. What is the gate which shows this characteristics? Yes, you're right. That is XOR gate or exclusive OR gate. So just draw its truth table. Output is 1 when both of its inputs are different. Otherwise, output is 0. That's it. I hope it is clear. Next part C is the only time that the output is 1 when both inputs are zeros. When both inputs are zeros, when both inputs are zeros, then output is 1. What might be that gate? What about NOR? If you apply 0 at both of its inputs, so 0 or with 0, 0, and then you invert it, output will be 1. Otherwise, if one of the inputs is 1, or both are 1, so output will be 0. So the only time output is 1 when both inputs are zeros, the gate is NOR gate. Fine. That is NOR gate. Because here you have to OR first and then you have to invert it. So when both of inputs are zeros, so 0 OR with 0 is 0, output of this OR gate, and then you invert it, so output is true. So this is asked that output is true only when both of its inputs are zeros. So output is true. You can now complete its truth table. Output is true when both of its inputs are zeros. For here, output will be 0. How? You have to OR them first and then you have to invert. 0 odd with 1 is 1, and then invert it, 0. 1 odd with 0, 1, and then invert it, 0. 1 odd with 1, 1, and then you invert it, output is 0. So that's it. I hope it is clear. Let's say we see another question. Year 2023. And here some logic expression is given to you. And first of all, you're asked to draw the logic circuit for this logic expression. It is given that each logic gate must have a maximum of 2 inputs. Fine. So let's see this sub expression first. This is A NAND B. This logic expression, you can also write down its Boolean expression, because when you are going to draw the truth table, it is more convenient, Otherwise, you can go as such, no problem. So A, this is and then not, whole not. This is A and B, A into B, and then whole complement. So call this as P. Then OR, and then not of this, B XOR C. Let me call this B XOR C, this sub expression as Q B XOR C. You can write down Boolean expression if you want. XOR symbol is this, B XOR C. This is Q. The not of Q. Fine, you can find out Q bar, which is not of Q. And then you have to OR what? You have to OR P. So Z will be this P, or symbol for OR is this P or Q bar. Fine. So ultimately, when you have to draw the truth table, so this will help you over there. Fine. So let's say we draw the logic circuit first. That is this sub expression A NAND B. So A, B, so A NAND B. Fine. So this is A NAND B. Let's say you call this as P. Then what next? You need Q first, which is B XOR C. B is this. C is, you can tap from here. B XOR C. So B XOR C. Which we had called Q, for instance. And then you need Q bar, which is not of all this. So this is Q, and then you have to not it to get Q bar. Fine. So this Q bar, and finally the output Z is P or Q bar, P or Q bar. So it means this P, or this is the symbol for or Q bar. So this is Z. That's it. So I hope it is clear. Fine. This logic diagram is in front of you. It is clear to you. Next, what we have to do is, next it is asked to draw the truth table. So to draw the truth table, we'll see what we have to build. We have to first draw the column for P, which is A and B. You can see from here as well, A into B and not of it, for instance, which is NAND. So P is A NAND B. So A NAND B, you can write down like this as well, A into B whole complement, which is A NAND B. This is P. Then you need Q, and we had seen Q is what? B XOR C. This is B XOR C, that is Q. So Q is B XOR C. This is the column for Q, B XOR C. Then you need Q bar as well, or not of Q. So you can write down not of Q or Q bar, whatever you like. And finally, Z is P or Q bar. P or Q bar. This is, Z, which is P or Q bar. Q bar is this, you can write down this as Q bar. So let's say quickly work out for this. So NAND, P is A NAND B. So A, you have to NAND these two columns, A and B. So NAND is, NAND is what? NAND is AND followed by NOT. So you have to AND them and then invert them. So 0 into 0, 0, invert 1. 0 into 0, 0, invert 1. 0 into 1, 0, invert 1. Sorry, invert 1. 0 into 1, 0, invert 1. 1 into 0, 0, invert 1. 1 into 0, 0, invert 1. 1 into 1, 1, invert 0. 1 into 1, 1, invert 0. So this is P. Then Q is what? That is B exclusive or C. Now you have to take this column and this column and XOR them. So exclusive OR, if you have two inputs, X and Y, and XOR them, output is 1 when both of inputs are different. Otherwise, output is 0. That is for exclusive OR. So Q is B XOR C. So you have to XOR these two columns. These two columns for B and C. So 0 XOR 0 is 0. 0 XOR 1, 1. 1 XOR 0, 1. 1 was same. So 0, same, output 0, different, output 1. Different, output 1, and same, output is 0. That's it. Next, you have to find out Q prime, or not of Q. I mean, not of this column. Just you have to invert this column. So against 0, 1, against 1, it is 0, 0, 1, 1, 0, 0, 1. That's it. And finally, what is Z? That is P or Q prime. P, which is this column, and Q prime, which is this particular column. P or Q prime, that is Z. So you have to OR them. So output of OR is 0 only when both of its inputs are zeros. So over here, 1, over here, 1, 1, 0, 1, 1, 1, 1, 1, 1 is 1. Then 1, 0 is 1, 0 OR with 0. Only over here, output is 0. 0 OR with 1 is 1. So that's it. So this is for Z. It's the truth table for this particular logic circuit. I hope it is clear. Fine. Let's move to some next question. And this is question year 2021, May, June, and it was in paper 2. This topic was before 2023, it was as a part of paper 1. So you can see some questions from there as well. So let's say this first question is said that consider this logic statement, not of A and B or C and B, and the NOR with B or C. Fine. So not of A and B. You can write down logic expression if you want. This is not of A is represented A prime and dot, or even you can write down directly. So A prime B is this sub expression. Then OR with, this has to be ORed with C, or mean this plus C. Fine. Then AND with this B. Fine. And then you have to NOR this whole with B or C. B or C is B or C, and you have to NOR these two. I mean this as well as this. So NOR is just like, plus, and then what? Whole complement. This is NOR, or you can just write down NOR if you feel convenient. Fine. So let's say we draw this A prime B. Fine. So first of all, not of A and B, not of A. This is written down like this, and B. So not of A and B, which is A prime B, for instance. Let's say we call this as, for instance, P. Let's say we call this as P. So this is P. And then you have to OR it with C. This whole OR with C. So it means you have to OR it with C. So C is, you can tap it from here. And then you have to OR with C. So P is this one, OR with C. So let's say this whole P OR with C, you call it, for instance, Q. I mean, till here, let's say you call it as Q. So this is Q. And then and all this with B. B is this. So and with B, and with B. So let's say you call this as R. Fine. For instance, you call this as R. So you had this complete expression till here as R, let's say. And then B or C, for instance, we just call as L. B or C. So B is this. C is this. B or C. Fine. This sub expression B or C, let's call this as L. And then finally what? Finally, this whole, which is this one, we had called it R, and this one called it L. We have to NOR them, R and L. So NOR R and L, and this is the final output X. That's it. So I hope it is clear. Fine. Next, you're supposed to write down its truth table. Fine. So for that, we see what are the expressions which are required. So first of all, you need A bar, then P is A bar and B. So first write down A bar or not of A, and then P, which is A bar into B. Let's just write down those sub expressions. B is what? A bar and B. Then Q is what? That is P or this or P or C. P or C, that is Q. P or C, that is Q. P or C, that is Q. Then R is what? R is Q and B, or B and Q, whatever you call. So R is this B into Q. So B into Q, that is R. Fine. That is R. And L is what? That is B or C. B or C. B or C. This L, that is B or C. B or C. And then finally, X is what? That is R nor L. So R nor L, you can write down like this, or you can write down like this as you like. So now we can quickly complete this. Fine. You can draw columns. So now we can quickly complete it. A prime, very simple, just not of A, this is this column. So just invert this. So 1, 1, 1, 1, 0, 0, 0, 0. Next is A prime, not of A and B. I mean, you have to AND this and this. Not of A and B. Not of A is this, B is this. You have to AND them. And you know, output of AND gate is 1 only when both of its inputs are 1. So here output is 0, 0, 1 into 1 is 1. 1 into 1 is 1. Again 0 into something 0, 0 into something 0, 1 into 0, 0, 1 into 0, 0. Next Q, which is P or C. P is this, C is this. So it means what we have to do is now we have to Q is P or C. P is this or C. C is this one. So we have to OR these two. And you know, output of OR is 0 only when both of its inputs are zeros. Otherwise, output is 1. So so you have to OR these two columns, this C as well as P. So 0 OR with 0 is 0. 1 OR with 0 is 1. 0 OR with 1 is 1. 1 OR with 1 is 1. 0 OR with 0 is 0. This 1 OR with 0 is 1. 0 OR with 0 is 0. 1 OR with 0 is 1. That's it. Next, this R, which is B and Q, R, which is what? B and Q. So B is this and Q is this. So B is this and Q is this. So R is B and Q. So you have to AND these two columns, this and this. And output of AND gate is 1 only when both of its inputs are 1. So 0 AND with 0 is 0. 0 into something 0. 1 into 1 is 1. 1 into 1, 1 into 1 is 1. Then 0 into something is 0. Then 0 into something is 0. Then 1 into 0 is 0. And 1 into 1 is 1. This 1 into 1 is 1. Next is what? L, that is B or C. Next, L, which is what? B or C. Where is B? B is this and C is this. So you have to OR these two columns. And output of OR gate is what? 0 only when both of its inputs are zeros. Otherwise, it is 1. So 0 OR with 0. 0. 0 OR with 1 is 1. 1 OR with 0 is 1. 1 OR with 1 is 1. 0 OR with 0 is 0. Then 1, 1, 1. And finally, what is X? X is R nor L. Nor is you have to OR them and then you have to invert it. Now you draw this output X over here. Just draw it, then I'll read it, read the question, and then you will see what you have to find out. In fact, it is given that the truth table is shown and X is given as a part of question, but then it is mentioned that there are 4 errors in the truth table in the output column. You have to identify those. So we can only identify if we ourselves solve the question and then find out the discrepancy, and then we can identify where the error lies. Fine. So just draw this R nor L. I mean, first you have to R. This is R. Me raise this. Now this time you have to nor R, which is this, L, which is this. So you have to nor these two columns. You have to nor these two columns. So for nor, you have to OR them first and then invert them. So you write down over here. Let me write down these outputs here. Fine. So you have to NOR these two columns, R and L. So 0 OR with 0, 0, then invert it, 1. 0 OR with 1, 1, then invert it, 0. 1 OR with 1, 1, then invert it, 0. Then 1 OR with 1, 1, invert 0. Then 0 OR with 0, 0, invert 1. 0 OR with 1, 1, invert 0. 0 OR with 1, 1, invert 0. 1 OR with 1, 1, invert 0. Now this is the actual output of X. And this is the given. This is given as a part of the question. And then it was asked that find out that there are 4 errors. Now you can see. Given was 1 and actual that we had find out, that is also 1. And this is first error. Given was 1, but actually it comes out 0. Similarly here, given was 1, but actually it is 0. So error. Fine. Okay. This is again okay. Okay. And here again error lies. Given was 1, but we found it is 0. Again, given was 1, we find out it is 0. So there are 4 errors which are asked to identify. and it is asked that identify those four incorrect outputs and write down the row number to identify each incorrect output. So first incorrect output is this one, which is row number 2. Second is this one, which is row number 3. Third is this one, which is row number 7. And fourth one is this one, which is row number 8. So row number 2, 3, 7, 8. That is your answer. Row number 2, 3, 7, 8. 2, 3, 7, 8. That's it. I hope it is clear. Let's move to the next question. Year 2020. This seems to be simple question. Identify the name and draw the single logic gate that replaced the given logic circuit. Identify the name and draw the single logic gate that can replace the given logic circuits. So this is some logic circuit, which is, for instance, composed of two gates. You have to identify the name and single logic gate that can replace this given circuit. So you know what is this? This is AND followed by NOT. AND followed by NOT. What is that gate? Yes, you're right. That is NAND gate. Fine. That is NAND gate. AND followed by NOT is AND. And then it is asked, you have to draw the gate. So you know this is symbol for NAND. So A, B, and output is X. That's it. Next. This is OR followed by NOT. OR followed by NOT. What is that? Yes, that is NOR. That is NOR gate. Fine. So OR followed by NOT is NOR gate. And you can draw its symbol. So A and B are the inputs, X is the output, and that's it. The next question is given to you that you have to draw the truth table for this logic statement. So let's say this sub expression is A or C, and not of A and not of C, and then XOR this with B. So first of all, you can see there is not of A and not of C. So you can draw the column of not of A. You can write down A prime, or if you can write down not of A, you can write down that as well. So not of A, which is A prime in fact, fine. So I use this notation because it takes less space. Otherwise, sometimes this working space becomes less if you write down all this. So only this is the reason. So not of A and not of C, you need that column as well, not of C. Then you need, for instance, see this expression, A or C. Let's say you call this as P, A or C. So we can find out P, which is A or C. So P as A or C. Then let's say call this as Q, which is not of A and not of C. So not of A and not of C is A prime into C prime. So let's say we call this as Q, which is A prime into C prime. Not of A and not of C. Let's say we call it as Q. And then what you have to do, you have to this P and this Q. So you have to get this P and then Q. So then P and Q, you may call it as R, which is P and Q, P into Q, that is R. So you had got all this sub expression. And finally, you have to XOR all this, which is R. So you have to R XOR this B, which is finally X. X is R XOR B. Sorry, this is B. R this whole XOR B. So R XOR symbol is this. B. So now we had written down different columns that we need and draw the lines. And next, fill these columns. So A primer, not of A, just invert it. So 1, 1, 1, 1, 0, 0, 0, 0. The next is you need C prime or not of C. So just invert this column. So 0, 1, 0, 1, it means 1, 0, 1, 0, 1, 0, 1, 0. You had just inverted this column, not of C. So it was 0, 1, 0, 1. So it is 1, 0, 1, 0, 1, 0, 1, 0. Next P, which is A or C. So A or C, you have to OR these two columns. P is A or C. Fine. So OR gate output is 0 only when both of its inputs are zeros. So here 0. Here one of the input is 1, so output is 1. Here both inputs are zeros, so 0. Here 1, 1 OR with 0 is 1, 1 OR with 1 is 1, 1 OR with 0 is 1, 1 OR with 1 is 1. And that's it. Next, Q. So Q is what? Q is, what is Q? That is A prime into C prime. A prime is this column, this one, and C prime is this column. So you have to AND these two columns, A prime and C prime, or not of A and not of C. This is in fact this sub-expression, not of A and not of C, not of A and not of C. So you have to AND these two, not of A, not of C. So AND, so output of AND gate is 1 only when both of its inputs are 1. So 1 into 1 is 1, 1 into 0 is 0, 1 into 1 is 1, 1 into 0 is 0, 0 into 1 0, then 0 into 0 is 0, 0 into 1 is 0, and 0 into 0 is 0. So you ended these two columns, this one and this one. And output is 1 where both of its inputs are 1. Here, here, and that's it. Next is R, which is P and Q. Fine. So R, which is what? So R is P and Q. So which column is P? This is P. This is Q. So R is P and Q. So you have to AND these columns, these two columns, P and Q. This column and this column. Fine, you have to AND them, P and Q. So output is 1 where both of its inputs are 1, otherwise 0. So 0 into 1 is 0, 1 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 0 is 0, 1 into 0 is 0, this is 0, and this is 0. So P and Q, fine, 0 into 1 is 0, 1 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, and so on. And finally, X is R exclusive or B. So what is R and what is B? So R is this one, this column, R, and B is this column. Fine. So you have to XOR these two columns. I mean, this column as well as this column. You have to XOR these two columns. R is exclusive or of, I mean, X is exclusive or of R and B. R is this column, B is this column. And you know exclusive OR symbol is this. You know its table if you have A and B inputs and XOR. So 0, 0, 0, 1, 1, 0, 1, 1. And you know output is 1 when its inputs are different. Otherwise, output is 0. So you can now XOR this column with this column. So 0 XOR with 0. Same 0, 0 or with 0, exclusive or, I mean exclusive or 0 is 0. This 1, 0 different, so output is 1. This 1, 0 different, so output is 1. Then this 0 with 0 same, so 0. And next this 0 or exclusive or with 0 same, so 0. Here this is 1, this 0, so different, so output is 1. And this is 1 exclusive of the 0, so different, so output is 1. And that's it. So I hope it is clear. Next, let's say we solve another question, year 20, and it is given the logic statement B and not of A, XOR A or C. So you have to draw the logic circuit. So you need not of A, so this is not of A, and with B, so this is, this is B. So you have to B and with not of A. So this is B, this is not of A. You have to AND them. This is this sub expression. Another you need A or C. So A, you can get A from here. This is A or C. Fine. A or C. And then you have to XOR these two sub expressions. Fine. So you have to XOR them. This is simple for exclusive OR, and that's it. So I hope it is clear. Fine. Next is asked to draw its truth table. So let's see what is required for truth table. First of all, you need not of A, which you can write down like this as well. Then this is B into not of A, or you can write down this as P, which is not of A into B. You can call this as P. You can find out this as well, which is A or C. You can call it as Q, which is A or C, A or C. And then X is exclusive or of P and Q. So this is X is what? P XOR P XOR Q. That's it. So now we can draw the truth table. So you need column for not of A. Just draw not of A or A prime, not of A. Next is P, which is A prime into B or not of A into B. P is this A prime into B or not of A and B. Then Q is A or C. Q is A or C. This is Q, which is A or C. And finally, X is P XOR Q. P XOR Q. So X is this P XOR Q. Fine. So now you can quickly write down these columns. These you can fill out these various columns. So A prime, just not of A, just invert this. So 1, 1, 1, 1, then 0, 0, 0, 0. Next P, which is A prime and B, which is A prime and B. So A prime is this, B is this. So you have to AND these two columns, A prime and B. So output of AND gate is 1 when both of its inputs are 1. So 0 into something, 0. 0 into something, 0. 1 into 1, 1. 1 into 1, 1. 0 into something, 0. 0 into something, 0. 1 into 0, 0. And 1 into 0 is 0. Next Q. What is Q? Q is A or C. So you have to OR these two columns, A or C. And you know output of OR gate is 0 only when both of its inputs are zeros. So 0, 0, so output is 0. Fine. Then 0 OR with 1, 1, 0 OR with 0, 0. Then 0 OR with 1, 1. Then 1 OR with 0, 1, 1 OR with 1, 1, 1 OR with 0, 1, 1 OR with 1 is 1. That's it. And finally, you know, X, which is P exclusive or Q. So it means now we have to do what? We have to do what? We have to P, this is P and this is Q. Fine. And we have to XOR P and Q. P and Q. We have to XOR these two. And you know, XOR, for XOR, you know, if A and B are the inputs, so XOR is the table 0, 0, 0, 1, 1, 0, 1, 1. So output is 1 when both of its inputs are different, otherwise 0. So just apply this for these two columns. So same 0, different 1, different 1, same 0, different 1, different 1, different 1, and different 1. That's it. So this is the truth table for this particular circuit. Fine. And that's it. I hope we had gone through some of the recent years papers and seen how these questions come in the exam from the Boolean logic chapter. Thank you very much.